So, welcome to the talk, which is called Who Shot the Cluster? My name is Marian. I'm working on Kubernetes at Google, exactly on logging and monitoring team of GKE. Oops. So today we are going to dive into the world of audit logs and how they can help you to answer the question, who shot the cluster? I don't know, does anyone remember that recently there was a case when Kubernetes cluster of one big car manufacturer was compromised? Does anyone knows? Yeah, okay. So that was done through unsecured Kubernetes dashboard. So they didn't have any password set on it, and I think this issue was discovered by a company called Redlog. So there's a company that performs some security monitoring of public cloud environments. So besides stealing some secrets and credentials from this Kubernetes cluster, they have also managed to deploy some crypto mining software. A few important notes from here. The first one, they have managed to hide their mining pool service. So they have used some unknown endpoints. Also, mining pool server was hidden behind some CDN services. So it was very difficult for anti-malware software to detect it. Also, they have set a small limit on CPU usage, so it was running really unnoticeable on their cluster. So there is a question, is it possible to find something like that? Is it possible to track down the problem, what has caused it? And good news, yes, we can do it. And for that, you should use audit logging. So does anyone knows already what is Kubernetes audit logging? Please raise your hand if you heard about it. And okay, and does everyone already using it on their clusters? Okay, that's not so good. So here you can see official definition of Kubernetes audit logging from documentation. But in simple words, it just, we are recording all requests made to the API, Kubernetes API server. Very important to understand that Kubernetes audit logging doesn't add any additional security level to your Kubernetes cluster. So probably you can build some log-based metrics and then define alerts that will recognize some anomalies in your cluster, but I would say that it's pretty difficult. It's better to set the correct airbag rules, correct firewalls. Yeah, so Kubernetes audit logs, as the same as the normal logs, they should be used to find a cause of the problem and not to find why, for example, and not to protect your binary from crashing. So let's jump directly to the demo. Let's check if it works. Yeah. So I have created a small cluster on Google Kubernetes engine. So let's check what we have running here. Yeah, it may take some time. It takes, oh, okay. So does some random names of pods, of deployments. Does anyone see something suspicious here? Yep, exactly. So that's a very simplified example. In your cluster, something much worse can be happening. But in this case, we have two deployments that has almost the same names, but in one, we are using normal small o. In the second one, someone has put 0 inside. Yeah, and if we dive deeply into this deployment, we can see that, for example, it uses some unknown image and so on. Let's try to remove it. So hopefully I will not make any mistypes. And let's check one. Yeah, so it was removed. And the next thing that we probably should do is try to find who has created this deployment. But let's do one more thing. So check that everything works as expected. Oh, so I have removed it, but it was restarted like 10 seconds ago. Actually, that gives me a good hint what's going on. Probably we have a different job running in our cluster that monitors this deployment, and if it's removed, then it recreates it. So let's go to Stackdriver Logging UI. So by default, in Google GKE, we are writing all admin activity logs to Stackdriver for free. Okay, let's scroll it a little bit down. So I have it here and here. So let's jump to advanced filter. Yeah. Let's check who has created request metadata name, and let's check our deployment route builder. Okay, so let's run it. Yeah, we see that it was recreated like 2 minutes ago. Let's see what we can find here. So a lot of interesting information, but we are interested like in authentication. So authentication info, we have here a service account for default namespace, for default. So that's already a bit strange because you shouldn't give such power to default service account. But let's try to check it. Who has given it? Like, I'm not going to spend your time. I have it already in my tab. So let's submit a filter. Yeah, it was created a bit more sooner. So let's give it a few seconds. Yep. Let's check it. So we can go inside, product payload, authentication info. Oh, so that was created by me. Yeah, probably I was making some experiments and forget to remove it. Yeah, my fault. Yeah, but that doesn't mean that I'm mining Bitcoin. So let's use some different way for finding our pod. Here we have also in the request metadata a caller IP that we can use actually to figure out from which node request was executed. Here we are getting node name, and now let's just check what is running here. And if you look on it, you can see almost the same pattern as we have seen before. Someone replaced small o with 0, and we have some malicious pod running in our system. You might wonder, like, is it a luck? Yeah, in this case, it's a luck and a simple demo. In real life, it may be not so easy to find it. You need to check every pod that runs on this node. But I have good news. So I was talking with Tim Claire. They are working on providing such thing as pod identity. So besides having a service account, you're also going to have information about pod identity, which gives you pod name from which request was executed. Yeah, so let's finish our demo and check who has created this pod. As before, everything is written already. Let's check it. Let's give it a one. And who is our attacker? And authentication info. Oh, that was also created by me, which means one of two things: either someone has stolen my credentials, or I'm mining Bitcoin on corp resources. Yeah. Now let's back to the demo, to slides. So to be useful, audit logs should answer next 7 questions, and now I'm going to show you where you can find answers to all of them. So the first one is what happened. So that was a pod created, was it deleted? Has someone got a config map or a secret? So we store this information in verb field of audit event. For resources, it contains information like create, update, delete. For non-resource objects like healthy, it just contains HTTP method name like put, post, etc. When did it happen? So it's pretty easy. We have a request received timestamp. Just check it. Also, in audit event, we have some deprecated fields, the timestamps that you shouldn't use. But also very interested is stage timestamp. You can use both of them, like request received timestamp or stage timestamp. That depends on your preferences. I'll explain the difference between them a bit later. The next question is who initiated it? Yeah, we have everything. We have user, we have impersonated user. Very important notes: if request was sent to unsecured port of API server, we are going to have like system unsecured here. Next question. On what did it happen? For this you can find in request URI or object graph field. Request URI can't satisfy us all the time. For example, if you are creating a deployment, then you don't have its name in request URI. You should look in object graph. Next question, where was it observed? So audit logging is a part of API server. It records all requests to the API server, so it was observed on API server. But you may wonder, what if we have some multi-cluster, let's say regional cluster running, and we have multiple instances of API server? Unfortunately, we don't have this information in audit event, but I will tell you how you can get it. From where was it initiated? So we have a list of source IPs. So it contains like original IP address and all proxies. Here, actually, we have one problem. There's a possible attack vector. So we are not performing any validation of the source IPs. So how we are building it, we are just looking on request header. There is a field which is called x4 from for, and actually attacker can put whatever he wants, so you can get in this list some trash actually. And to where was it going? And unfortunately for this question, we also don't have any answer inside of audit event. So you can imagine that some resource changes originated to etcd, but for example, if you're interested in your cluster metrics, possibly a request was originated to metric server. But you can get some information about destination based on request URI. Sometimes people ask why they can't use events. So there is a big difference between events and audit logs. Audit logs, that's something generated by API server. For example, even if you create a new event, corresponding audit log is going to be created. Events, at the same time, that's just a simple Kubernetes resources that can be generated by any component running in your cluster. And they I would say, contain information like why one or another thing has happened, like why deployment was scaled, why a container was restarted. So you should look on events as something complementary to audit logs. The next thing is Kubernetes API server logs. Has anyone used them to find requests that have made to API server? Okay. Yeah. So probably that was a good idea when we didn't have audit logs, but now I would say that not needed anymore. So why you shouldn't use Kubernetes API server logs? So first of all, you can configure information that you are receiving there. A second one, that's just API server logs, so it's going to contain all information. And if you increase verbosity, that's just going to be a lot of noise inside. And the most important point that they just doesn't have enough information inside. So for example, that's copied from Kubernetes API server logs, that's entry that was related to creation of this malicious deployment. Yeah, it doesn't have any name. You can play and replace up with some kubelet or something like that. So I wouldn't recommend to use it. And the last point is a bit subjective, I would say. I think that each thing should have only one purpose. And in this case, Kubernetes API server logs should be used to debug problems with API server, not problems with Kubernetes cluster. Now we can go a bit and talk a bit about how audit logging implemented on API server. So from implementation point of view, that's just a simple filter that we have in request chain. It's located exactly after authentication. So if audit event says that this action was executed by user A, then we can actually believe that it was executed by user A. Now, how you can store these logs? Currently, we have two different ways. One is writing to the log file using log backend, and the other one is sending audit logs to remote API using webhook backend. And actually, you can use both of them at the same time if you need it. Now coming back to the question, how we can find out from which API server, on which API server we have observed one or another request. So we can configure, for example, fluentd to add this information to the log, or you can get it if you get this information from original IP address of the request on your remote API. One another important point about this diagram, that it's a blocking way of writing audit logs, which means that if you have some audit log pending, then you're not going to proceed with request until it's written to log file or remote API. If you don't need it, then you can use batching strategy. In this case, we are adding buffer in front of our backends, and we have some go routines that continuously checking it. And if buffer has, for example, by default, that's 400 events, not even audit log events, then they are sent to webhook backend or to log backend and processed later. Now, a few words about stages. Not everyone understands that each request to the API server actually can generate multiple audit logs. So how it works? Once audit filter receives a request, then a first audit log is generated, which is, and this stage is called request received stage. The next, we are processing our request, and here we have two different passes depending on type of your request. So if it's something long running like watch, then we are going to the stage which is called response started stage. At this point, another audit log is generated. And once we have sent the last byte to our client, then we are coming to response complete stage. And here we also have a new audit log. And as you remember, previously I was mentioning stage timestamp. So stage timestamp, that's timestamp when request achieved each stage. Yeah, so how you can configure audit logging? So the most important point, you should pass audit policy file to your API server. So let's check how it's going to look. So for example, we want to record all pods and nodes statuses updates made by kubelet. So on the first line, we are specifying level. Level is that some kind of verbosity of our audit log. So we have 4 types. The first one is none. That means that you are not interested in this at all. A second one is metadata. It includes information such as user, timestamp, caller IP address, etc. The next one is request, the same as metadata plus request body. And the last one is request response. So that's metadata, request body, and response body. Next, we are specifying users, verbs, and resources. If you omit users, it means that this rule is going to be applied to all of them. And in the last line, we are specifying which stages we should skip. So if you are not interested in generating on each of those stages a separate audit log, so then you should specify here which one of them you should skip. You may ask why in this case we are skipping request received. So it means that audit log is going to be generated on response complete. Considering that we don't want any response body. Does anyone has some ideas why we are doing this? Anyone? Okay, so the problem is that on the last stage, we are also making some modifications to metadata. So for example, we are adding response code. So you know if you have 200 that your request has succeeded, otherwise it hasn't. And yep, let's go to the short summary. So first, the most important point, audit logging doesn't provide any additional security level to Kubernetes cluster. The second one, audit logging should be used for tracking down problems in your cluster. So that's not only some malicious deployments, that could be also mistakes of developers or some data that you can use later for postmortems, so you can improve processes inside of your organization. Audit logs are very easy configurable and processable, so I have shown in the demo on Stackdriver. And I think that audit logs should be enabled in every cluster by default, so their amount is not as big comparing to all other logs that possibly coming from your applications, but I would say that they bring a lot to everyone. And yep, that's all from my side. Does anyone has some questions related? Yep. Maybe let's bring you. Please, could you use the mic?
It's possible to have also on the response on the audit log what is changed on the resource. So
yes.
If it's a deployment, what kind of if fields are changed?
When you are changing something, you are sending a request body. Yeah. So by default, so you can get this information from request body. Unfortunately, we are not like processing it and storing a div, a real div, but yeah.
So I can combine this with other information.
Sorry.
I can combine this with.
Yeah, you should compare it by yourself. Okay. But maybe in the future that's going to be done.
Okay.
Any other questions? Yes, there's questions.
So you say audit log, is that like a special logging or is that the only logging that takes place? And
sorry, could you repeat the question?
Is this the only logging that takes place, the audit log? I'm fairly new to Kubernetes here.
I'm not sure that I have understood. Like,
well, in a Linux system, I have normal logging, and then I have the audit, which is much higher volume.
No, these specific logs are related only to requests that have been sent to API server. So, of course, you can have also some logs from Linux kernel, but that's completely different. The goal of these logs is to give you information what has happened in your cluster. So, for example, let's say someone SSH into your node and created some binary that's mining Bitcoin. You are not going to get this information from Kubernetes Audit Logs because no requests have been sent to API server.
Okay, and the logs are created on the master?
Yeah, they are created on the master, and yes, they can be stored to log file or sent to remote API.
Oh, okay, thank you.
Sure. Yep.
So, I think you mentioned that we have to enable the audit logging by default for cluster is recommended. I completely agree with that. So do you have any performance number on that? Because I mean, if I enable, I would want to make sure that the performance is not sacrificed.
By performance number, you mean how much resources are consumed by audit filter?
Yeah.
So I don't have exact numbers, but I would say like in memory and CPU, it's negligible compared to everything else that happens on API server. But if you're asking about volume of logs that are generated, that's a bit tricky question because everything depends on the cluster. So we have seen situations when 3-node cluster was generating much more logs compared to, let's say, 100-node cluster. So it depends on how dynamic your cluster is. And yeah, actually, there is some ways to generate really a lot of them by appending some random information to annotations, let's say. And if you are storing request and response bodies, that's going to be huge. Yep.
Hi. Excuse me. I just wanted to share a small war story regarding this. One of our production clusters got infected by this bit mining. And what they did was they accessed through the Kubernetes port, which was unprotected because of my silliness. And they checked the list of running containers, found one of the containers with curl in it, and then he called the curl to pull a binary from somewhere, and that binary in turn ran the mining software containing limits on CPU, limiting to 50%. I saw that. So we were able to figure all of this out. Today I'm telling you all this because we were able to figure all of this out by just the service level logs of Kubernetes API server and kubelets service, the regular service logs. And we have still not enabled the audit log because we thought it would be a huge tax on the CPU and perhaps the storage. We did fix the security firewall rules to not allow kubelet access from everywhere anymore. But this was my war story. Yeah.
Okay, thanks for sharing.
Hi, thanks for the talk. I was wondering if you can recommend tooling that I would use if I want to get notified about some certain events that I'm interested in. So I'm not going to actively look at the log files and search for something, but I get notified. Do you have any suggestion on that?
Honestly, I don't have any suggestions. So I know that you can configure it through the stack driver, but as I have taught, building correct metrics and alerts that will notice something wrong with based on the information from audio logging may be tricky. So right now I don't have any information about it. Sorry. Next question.
So the question is about the audit logs for the Linux kernel. For example, someone gets into the perimeter and SSHs into the node and does some sudo commands. So what's the best solution to record something like that? Because currently we're using the audit bit from Elasticsearch, the container running on each node, and then it exports all the events which happen on the kernel level on the Linux, and it sends it to Elasticsearch. But is there anything better?
Right now, it's a bit difficult to answer this question, so
I
can ask.
Google doesn't give this opportunity out of the box with the.
Sorry, could you repeat?
I know that Google Kubernetes engine does not provide this functionality out of the box, right?
So as far as I know, we are working on providing audit logs from nodes. So not the Kubernetes one, but from VM level. But I need to ask colleagues to confirm what's the current status of this.
All right, thank you.
So if there are no questions, thank you for your attention. Have a nice day.